Welcome back again to Tech Talks Education. In this session, we are going to look at Avogadro's principle and the molar gas volume. Avogadro's principle and the molar gas volume. So let us start with what we call Avogadro's principle. Can you remember Avogadro? I told you something earlier that Avogadro is the father of the mole. He is the one who came up with the number of particles in one mole being 6.02 times 10 raised to the power 23. That's the number of particles in one mole of a compound. So it is the same Avogadro that came up with the principle that we are going to see. And that principle was used for coming up with what we call the molar gas volume. So let us look at Avogadro's principle. A principle is almost like a law, only that a law is supposed to be quoted. So a principle is just a step away from a law. So it's almost like we are talking of Avogadro's law, almost. But it is at the level of a principle which is so close to a law. So we cannot quote it. Now let us try to see the work of Avogadro that made him to come up with a principle called Avogadro's principle. What Avogadro did was he collected samples of gases. He picked different gases. Let me assume that Avogadro used nitrogen gas. Let me use the name nitrogen gas. He picked oxygen gas. He picked, say, carbon dioxide gas. He picked, say, ammonia gas. So Avogadro collected different samples of gases, and then he made sure that he used the same volume of these gases. So assuming that Avogadro used 50 cubic centimeters of nitrogen, it means that he also used 50 cubic centimeters of oxygen. He also used the same volume of carbon dioxide and the same volume of ammonia. Let us say these are the four gases that Avogadro used. Then he subjected these gases to the same conditions of temperature and pressure. Equal temperature, equal pressure, the same temperature. He subjected these different gases to the same conditions of temperature and pressure. Then he started looking for the number of moles in them. So he found out that in this case, the number of moles of these different gases having the same volume and subjected to the same conditions of temperature and pressure, he found that if nitrogen gas in the 50 cubic centimeters, if there was 0.1 mole, then he found that even oxygen had the same number of mole, that is 0.1 mole. If carbon dioxide, 50 cubic centimeter, he looked for the number of moles in it, he also found that they were the same, 0.1 mole. Even ammonia had also 0.1 mole. This was his finding. So from his finding, he therefore came up with a principle, which I said is almost a law, which governs different samples of different gases. Different samples of different gases. I say that he used equal volume of those gases, but he subjected them to the same conditions of temperature and pressure. Equal temperature, equal pressure. Then he looked for number of moles in them. He found that they were just the same. This is a wonderful work of Avogadro, which made him to come up with a principle. So let us look at Avogadro's principle, what it states. So from this work we can state Avogadro's principle. Avogadro stated that in his principle, he stated that equal volume of all gases under the same conditions of temperature and pressure have equal number of moles. So this is what we call a statement of Avogadro's principle. Equal volume of all gases. Remember, all gases, not just some gases, but all gases, provided that they are under the same conditions of temperature and pressure, they have the same or equal number of moles. So Avogadro's principle was then used for developing what we call the molar gas volume. So let us also look at the molar gas volume. So this molar gas volume is a brainchild of the work of Avogadro. So this one here, the molar gas volume, was got from Avogadro's work, from Avogadro's principle. Equal volume of all gases under the same conditions of temperature and pressure have equal number of moles. Now let us look at the molar gas volume. Molar in this case refers to 1 mole. Molar refers to 1 mole. So when I talk of the molar gas volume, it is the volume of 1 mole of a gas under certain standard conditions of temperature and pressure. So the molar gas volume is the volume of 1 mole of a gas, the volume of 1 mole of a gas under certain standard conditions, of temperature and pressure. Now we need to see the conditions of temperature and pressure used in this case for getting the volume of 1 mole of a gas in this case. So you can see we are talking of 1 mole, equal number of moles. Here Avogadro's principle says that equal volume of all gases have got the same number of moles. It means that equal number of moles also of all gases, provided that the temperature and pressure are the same, they will also have equal what? Volume. So if I have 1 mole of a gas under certain conditions of temperature and pressure, I will find that it has got some number of moles, or in this case if I have 1 mole, it will have got some volume, which is true for all gases. So it makes us to look at the values of the molar gas volume at certain conditions of temperature and pressure. Now the conditions of temperature and pressure in this case are: 1, we have what we call room temperature, at room temperature, and then at what we call standard temperature and pressure. Standard temperature and pressure. So sometimes we can give it the acronym STP, which is always used so freely. So we have 2 different conditions here of room temperature and then the standard temperature and pressure. Now let us try to look at the molar gas volume at room temperature and then the molar gas volume at STP, which are just the same because these are different standard conditions, but they are applicable to all gases In this case, not liquids, not solids, we are talking of gases only. So let us try to see in this case, starting with the first one, that is at room temperature. So 1 mole, molar gas volume, the volume of 1 mole of a gas at room temperature. 1 mole of a gas at room temperature, it has a volume, that means its space which it occupies is 24 liters, and the 24 liters is the same as 24 cubic decimeters. Now, in terms of cubic centimeters, this value here we can multiply by 1000 and it gives us 24,000 cubic centimeters. So this is the molar gas volume at room temperature. So 1 mole of a gas at room temperature, equal volume of all gases under the same conditions of temperature and pressure, has got the same volume in this case, or the same number of moles, same volume. That is with it, the molar gas volume at room temperature. Then 2, let us look also at STP. So 1 mole of a gas at standard temperature and pressure, which is STP, it occupies 22.4 liters, and 20 liters in this case the same as cubic decimeters. So it is also 22.4 cubic decimeters, and multiplying by 1000 to get cubic centimeters, it will be 22,400 cubic centimeters. So the values of the molar gas volume at room temperature and at standard temperature and pressure are always given for a candidate to use in the calculations that we are going to see but later. So it can be given either on the front page, that is the first page of your question paper, or against each question, or at the end of a question. If they know you are going to use it, then they will give you the molar gas volume at that very condition. So do not so much get disturbed, because this one we shall be given just free of charge, just like the relative atomic masses. But it is imperative for a learner to also be able to remember the molar gas volume at room temperature, these values here, remember all of them. And then even at STP, you should be able to remember. So that's what we call Avogadro's principle, and that's what we call the molar gas volume. So we are now going to look at next how to use these values of the molar gas volume at room temperature and at STP to carry out our calculations. So thank you so much for watching. This is Tech Talks Education.